Hey guys, Mr. Barnes here, and I'm going to take you to a couple of. This is specifically for 2204. Um, wouldn't hurt 2205 to watch this video though as well. Although you won't have something as of this nature, I don't think, on your common exam. Like I said in two previous videos I posted, those are what I think would be the two possible examples that could show up. But again, this could be a multiple choice, or you never really know. You could be a long answer as well. Um, So our goal here is to find the possible values of theta. So the first thing we have to do is rearrange this for sine theta. So we go sine theta is equal to -3, or negative root 3, over 2. And at this point, we note, just it's just a procedure I follow anyway, that sine is negative. Okay? Sine is negative. So I'm going to now use that fact, use this to be able to find my solutions for theta. First, what I'm going to do is I'm going to find any related angles to theta. So I find my related angles, sine -1, by going sine -1. Fix that. So I go sine -1, and to find your related angle, you always take the positive of whatever you have here. The reason being is because you're going to get an answer between 0 and 90. Okay, and that's your definition of related angle, an acute angle, basically. So in order to get an acute angle here, you need to take the positive value, and basically it's going to give us something in the first quadrant. Okay, so sine -1 of root 3 over 2, that's 60. Okay, that's just from your unit circle. If you want to do it on your calculator, you can do it on your calculator as well. So that tells me my related angle is 60. Now, this is where we go back to the fact that sine is actually negative. So what we have to do is look at our cast rule. So my cast rule says that sine is negative in the third and the fourth quadrant. Here, cos is positive, all are positive, sine is positive, and tangent is positive. So here we have sine to be negative in my third and fourth quadrant. So what that means is 60 is not actually a solution. 60 is just my related angle to these two of these solutions that's in this and in these two quadrants. So we also know from the cast rule that here my theta is equal to RA. Here we have 180 minus RA. Here we have 180 plus RA. And here we have 360 minus RA. Alright, so now what I do to find my theta, the theta is going to be 180 plus 60, so that's going to be 240. And then I have theta over here, so it's going to be 360 minus 60, so that's going to be 300 degrees. So these are my two values for theta. Okay, so if I go up here and I want to check that answer, well, actually I'll just take it my WebEmu here, and if I want to check that answer, this is what I had to do. So I know that my sine theta is equal to negative root 3 over 2. Okay, so if I go sine 240, I get this. So that's the decimal approximation of root 3 over 2 with a negative. And then I go sine 300, I get the same thing. So yes, I am correct. Alright, so if you remember on Friday, the last thing we were doing in class was we were solving one that looked like this. Okay, and this is on Common Exam from June 2010. We were solving this, but then we had an announcement where we had to go down to the gym and we didn't get to finish this question thoroughly. So I thought I might just do a video of it so that way you'd at least have an idea of where this thing was going. We did this, again, we did an example like this on our assignment. You had one this a little bit harder like this than on our test. You had one with secant or cosecant. I can't quite remember in one of these things. So again, you've seen this. Thought I just might do a video to refresh your memory on it. So this looks a lot like FOIL. What it looks like when we have something in factored form, but we're not going to FOIL it. What we're going to do is we're going to use the zero property. Okay, so the zero property states that in order for this thing to be equal, one of these brackets has to be equal to 0 or both. So what we're going to do is break this up into two mini problems. So we have 2 sine theta minus root 3, and that's going to be equal to 0. And then the second mini problem, which is cos theta plus 1/2 is equal to 0. So I broke it up into two mini problems, which I now have to solve using cast. Alright, so let's do this. So over here, I'm going to solve for sine theta again. So I have sine theta is equal to root 3 over 2. And I'll note here, sine is positive. Alright, so my RA is equal to sine -1, which is root 3 over 2, and that's going to be equal to 60. Alrighty, so now I put my cast rule into effect. So C-A-S-T. So my cast rule states that sine is positive in quadrant 1 and 2. So in quadrant 1, my theta is going to be equal to just 60. And in quadrant 2, my theta is going to be equal to 180 minus 60, which is going to be 120 degrees. So that gives me my two solutions there. Okay? So now what we need to do is go ahead and solve this one right here. Okay? So I have, what I'm going to do, I'm going to solve it for cos. So cos theta is equal to -1/2. So then I'm going to take theta. Actually, nope. And that's a common mistake, to think you're solving for theta at this point. Using the method that I use, you're not solving for theta, you're solving for the related angle. Reason being is because we always take the positive of what's equal to give us our related angle, so we can use the cast rule. Okay, so cos -1 of 1/2, that's going to be 60. Okay, again, checking on your calculator if you need be. And then we got to use the cast rule again. So C-A-S-T. So where is cos negative? Because cos is negative right here. It's -1/2. Cos is negative in S and T, and that's quadrant 2 and 3. So we're going to have theta is equal to 180 minus 60. There's going to be another 120. And theta is equal to 180 plus 60, which is 240. Alright, so now I'll collect all my thetas and present my solution. So theta could be 60. 120, I don't need to list 120 again. I leave those two solutions, and 240. Okay, so those are my possible thetas. I circle my answer, make sure I show it, and hope this helps, guys. Good luck studying.